Hello students, how are you all? I hope you keeping well and doing well. So, I am Priyanka Singh and I am your science teacher. From today, I am starting chapter number 12. And from this chapter, unit 4 is starting. Moving things, people and ideas. And the name of this chapter is Motion and Time. So, let's start. Introduction. There are various kinds of things in the environment. Some of them are stationary, whereas many of them move from one place to another. Moving a car, rolling a ball, a walking boy are some examples of the moving objects. Some of the objects shown very slow movement, whereas many of them move fast. Trees, buildings, electrical poles, etc. are not in motion. They are said to be at rest. So, we see there are two types of object. These are the objects which do not change their position with time. The objects which do not change their position with time are said to be at rest. The objects which change their position with time. The objects which change their position with time are said to be in motion. The same object may be at rest at one moment and in motion at some other. The states of rest and motion are relative. Nothing is at absolute rest or in absolute motion in the universe. Any object said to be in the state of rest or motion is relative to a fixed point. Such a fixed point is chosen arbitrarily. Let us imagine ourselves to be sitting inside a compartment of a running train. Take a situation when everybody in the compartment is sitting at rest. Then each passenger is at rest relative to their compartment as well as with respect to other passengers. But if we consider any point outside the compartment, example platform, as a reference point, then the compartment as well as passengers in it are in motion. This example shows that the same object may be at rest with respect to one reference point and in motion with respect to another at the same time. So we can say that the motion is actually a relative motion and the state of rest and motion are relative. Types of motion. In your previous class, you have read about the types of motion. Just to recall them, various types of motion we generally observe are illustrated on the next page. So, these are the various motions. Okay. So, see these pictures and observe them. Translatory motion, linear motion, curvilinear motion, random motion, rotary motion, rolling motion, periodic motion, oscillatory motion, vibratory motion. We all realize the importance of time. You always try to reach your school in time. If you are late, you may be punished. If you get late to railway station, you may miss your train. Thus, there are many instances which tells us the importance of time. For example, the unit of time used by them was the time interval between sunrise or sunset or to the next sunrise. One full moon to another full moon. From one season to another, etc. These time intervals, however, could not be used as a standard unit of time because of the following reasons. These time intervals are so long. These time intervals change from place to place and from time to time. Based on the periodic nature of these phenomena, ancient people made devices such as sundial, hourglass or sand clock, water clock, etc. for measuring time. Sundial. It measures time by position of the sun. It has a stick out in the center of a circular disc The position and length of the shadow of the stick on the dial gives an indication of time. The limitation of this instrument is that it cannot function during cloudy weather and at night. Water clock. In a water clock, water is allowed to flow out from a hole made at the bottom of a bowl-shaped container into another bowl kept below. The emptying of the water-filled bowl to different levels corresponds scientific time periods. Sand clock. The sand clock or hourglass consists of two bulb-shaped containers made of glass and connected through a narrow glass tube. Sand is filled in one of the containers. The clock is kept on a plane surface with a filled container at the top. When all the sand trickles down to the lower container, a definite time period, usually an hour, is over. Units of time. The standard unit of time is second. The unit second is denoted by the letter S. Bigger unit of time are minute, that is MIN, hour, H, day, D, year, Y, etc. 1 minute is equals to 60 seconds, or we can say 1 minute is equals to 60 seconds. We can use abbreviation of minute as MIN and seconds as SEC. 1 hour is equals to 60 minute, or 1 H, that is hour, is equals to 60 MIN, that is minute. 1 day is equals to 24 hour, or 1 D is equals to 24 H. D denotes day and H denotes hour. 1 year is equals to 365 days, or we can say 1 by Y denotes year, or it is equals to 365 D. D is days. The time taken by the Earth to complete one's rotation about its axis is called a day. The time taken by the Earth to complete one revolution around the Sun is called a year. Measurement of time. We need to measure intervals of time which are much shorter than a day. Clock and watches are rather complex, but all of them use the principle of periodic motion for measuring time. We have learnt in previous class that a motion which repeats itself at regular interval of time is called periodic motion. One of the most common devices which shows periodic motion is a simple pendulum. Simple pendulum. A simple pendulum is a device that completes each to and fro motion in exactly the same time. It was discovered by the great Italian scientist Galileo Galilei. A simple pendulum consists of a heavy object like a stone or a metal ball tied to an end of a very light, unstretchable string. The heavy object hangs freely from the string. The heavy object is called the bob of the pendulum. The normal or the resting position of the bob, called its mean position, is displayed from its mean position taken to a side and released. The bob sets into a to and fro motion about its mean position. This to and fro motion of the bob about its position is called oscillatory motion. If initially the bob is displayed from its mean position, say O to point A, and released, it comes back to its mean position, does not stop, and continues to move forward to point B. From there, again comes back towards the mean position. The distance between points B and O is equal to the distance between point A and O. The motion of the bob starting from point O to point A, then A to B via O, and finally back to O from B is counted as one oscillation. An extra mile. To count one oscillation from an extreme point, the bob must travel the whole path from one extreme to the other twice via the mean position and reach back the starting point. Point A and B are called the extreme positions beyond which the bob does not move. The counting of one oscillation can be started from any of the extreme points, taking care that the oscillation is complete. When the bob comes back to the starting point, the time taken by the bob to complete one oscillation is known as the time period of the pendulum. Time period is expressed in seconds. So children, this is the example. See these examples and try to understand them and also practice them in your copies. Example 1, 2 and 3. Now, speed and average speed. Objects may travel fast or slow. The most convenient way to find out which of the two or more objects is moving faster is to compare the distances moved by them in a unit time. Speed of a moving object is the distance traveled by it in unit time. We know that the distance covered by an object and the time taken by it to cover that particular distance. We can calculate the speed of that object by using the formula. That is, speed is equals to distance travel by time taken. Suppose a car travels a distance of 360 km in 4 hours, then its speed will be speed is equals to distance traveled divided by time taken. That is, 360 divided by 40 is equals to 90 km per hour. Thus, the speed of this car is 90 km per hour. Units of speed. As per definition, we can write unit of speed is equals to unit of distance divided by unit of time. The SI unit of distance is meter, that is m, and that of time is second, that is s. Therefore, SI unit of speed is equals to meter divided by seconds. Is equals to meter per second. The unit meter per second can be written as meter per second or meter raised to the power s1. Since speed varies from very slow to very fast, the SI unit meter per second is not suitable to express all the speed. Therefore, speed can be expressed in many different units as described below. So students, are you able to see the chart? This chart is showing the unit of time and unit of speed. Unit of distance, unit of time, unit of speed in words or in notation. First one is centimeter, unit of time second, unit of speed in words centimeter per second, in notation that is cm/s, or we can also write it as centimeter per second. Second, meter, unit of time minute, unit of speed in words meter per minute. In notation, it is meter per minute, that is m/min. Third one is kilometer. R, kilometer per hour, km/h. Generally, the vehicles like cars, buses, trucks, trains, aeroplanes, etc. travel longer distances. Also, the time taken by each one of them is of longer duration. Hence, it is inconvenient to express the distance in meters and time in seconds. Therefore, to express the speed of vehicles and some other objects, a bigger unit, that is kilometer per hour, is used. The speed of slow moving bodies are commonly expressed in the units of centimeter per second, that is cm/s, or meter per minute, that is m/min. Average speed. When we say that a car is moving with a speed of 60 km per hour, we usually consider only the total distance covered by it in 1 hour. We do not bother whether the car has been moving with a constant speed or not. During that hour, the speed calculated here is actually the average speed of the car. So, average speed is calculated by dividing total distance traveled by an object by the total time taken to travel this distance. Thus, in this book, we shall use the term speed for average speed. The average speed of a moving vehicle may be different for different intervals of time. In general, all measured speeds are average speeds. The various forms of the relationship. Speed is equals to distance traveled divided by time taken, or V is equals to S divided by T. Distance traveled, speed into time taken, or S is equals to V into T. Time taken, distance traveled divided by speed, or T is equals to S divided by V. So students, please go through these examples and try to understand, or also do them in your copy. Example 1, example 2 and example 3. Speedometer and odometer. If we look at the dashboard of the car, we find many instruments on it. Speedometer is an instrument on a vehicle dashboard which indicates the speed of the vehicle at that instant of time in kilometers per hour. Odometer is an instrument which shows the distance traveled by vehicle in kilometers. The meters fitted on the top of handles of scooter and motorcycles are inbuilt speedometer and odometer, as shown in the picture. So students, there is another example which is given. So go through it and also try to solve it. Uniform and non-uniform motion. If a moving body covers equal distance in equal intervals of time, it is said to be in uniform motion. On the other hand, if a moving body covers unequal distances in equal intervals of time or equal distances in unequal intervals of time, it is said to be in non-uniform motion. Therefore, the speed of the body in non-uniform motion keeps on changing, whereas it does not change or remain constant in uniform motion. Graphical presentation of speed. We can also present a given information in the pictorial form. The data presented in the form of picture is called a pictograph. The presentation of an information or data in the form of a graph is called graphical presentation. Graph. Graphs are of various types. These are bar graphs. Graphs shown in the form of bars, pie chart and line graph. These are the types of graph. Okay. The first one is bar graph, the second one is line graph, and the third one is pie graph. A graph is drawn on a graph paper or a graph sheet. Let us learn about elements of graph. A graph paper is divided into equal parts by two perpendicular lines meeting at a common point O, which is known as the origin of the graph. The perpendicular lines are known as the axes of the graph. As shown in the figure, the horizontal line XOX is known as the x-axis and the vertical line YOY is known as the y-axis of the graph. The values of two given quantities presented in a tabular form comprises of data. An appropriate scale is chosen to represent the values of the two given quantities. To draw a graph, following three steps are followed. Drawing axis, choosing an appropriate scale, presentation of data on the two axes. Some other distance time graphs. When the speed of an object is not uniform during the course of its motion, the distance time graph are different from that shown below. So these are the different types of graph. The first one is the distance time graph for a body at rest is a straight line parallel to the time axis. And the next one is the distance time graph for a body moving with an increasing non-uniform speed is a rising curve. And the third one is the distance time graph for a body moving with a decreasing non-uniform speed is a curve reaching limiting values of distance. And the fourth one is the distance time graph for a body moving with the decreasing non-uniform speed is a curve reaching limiting values of distance. So students, there is an example, so go through it and try to solve it. It's time for Reader's Digest. The standard unit of time is second. One of the most common devices which shows periodic motion is a simple pendulum. Graphs are of various types: bar graph, pie chart and line graph. So students, it's time to take your leave. We'll meet in the next class. Bye.